Hi, welcome back to Missing Chemistry. This is electromagnetic spectrum problem number 4 lesson. Okay, let's look at the problem. Right here it is. The wavelength of violet light is 400 nanometers. What is the frequency of this radiation? Well, the first thing we have to do is we have to convert nanometers into meters. Okay, so we're going to use this formula here that 1 meter is equal to 1.0 times 10 to the 9 nanometers. So let's go ahead and do this. We go 400 nanometers, right, times 1 meter divided by 1.0 times 10 to the 9 nanometers. When we do that, we get the answer to be, let's see here, it's going to be 4.0 times 10 to the negative 7 meters. 4.0 times 10 to the negative 7 meters. Okay, now we can use the formula C equals lambda V, where the speed of light is C. We could either use 3.0 times 10 to the 8 meters per second, or 2.99 times 10 to the 8 meters per second. Remember that lambda is wavelength and V is frequency. Okay, so now we're going to solve for frequency. So let's go ahead and do this. So remember, we have the formula C equals lambda V. Now we need to isolate for frequency. That's V. So V equals C over lambda. Pretty darn snarly, I would say. So let's go ahead and plug in our information. V equals 3.0 times 10 to the 8 meters per second divided by our wavelength, which was 4.0 times 10 to the negative 7 meters, right? So this is going to give us the bottom 4.0 times 10 to the negative 7 meters. Now watch what happens. The meters will cancel out. And when we do the math, we find out that the frequency is going to equal 7.5 times 10 to the 14 1 over s minus 1. You could also write that as V equals 7.5 times 10 to the 14 hertz. Either unit is correct. Well, that's it for this lesson, guys. You be snarly, and we'll see you back here at Missing Chemistry.